Okay, boleh buka kamera sekejap. Okay, I see here Zuhair, Iqbah, Amirul, Argia, Rafi, okay, Alvin, Faiz, Fatimatul, future process. Okay, thank you Khairil. Orang lain semua gelap ya ni. Okay, Faisal Delhi, Al-Fawaz. You hear me?
Yes, doctor.
Okay. In collection of sample, okay, what we call it rational subgrouping, sampling, rational subgroup. There are two approaches for data collection. You follow my question?
Yes, doctor.
Okay, what are these two approaches for data collection? We have two approaches for data collection. You attend the class, last class?
Yes, doctor, but I can find my note about that.
You can find, so you don't understand.
Yes, actually, honestly, don't.
Okay, can anyone help?
Sorry, doctor.
Okay, Lukman, what are two methods for rational subgroup?
Instant time period and period of time, doctor.
Very good. Siapa ni? Fatimatul. Okay,
Yes,
betul.
doctor.
Yes, correct. Okay, instant time period and period of time. What is the difference between these two, Fatimatul?
So basically for the instant time, we take it at for example at AM, and the mean is sensitive, and for the range is the variation dia less variation.
Okay.
And for the period of time, we take the sample between, for example, 8 until 8:30.
Okay.
And it opposite with the instant time, because the mean for the mean we can see that the variation is less, but it more sensitive for the range.
All right. Very good. Okay, very good. So the method of data collecting data ataupun sample is very important. It will influence sensitivity of control chart that we produce. Okay, as if you take an instant time period, instant meaning that particular moment you take all your sample, let's say at 9 a.m. So all the sample for 5 unit of sample, n equal to 5, you take it at that particular moment. Okay, so the problem here is the sensitivity of X bar chart is no good. Okay, because you take only that particular instance. Okay, so another method is we call it period of time. Okay, period of time where the data is collected during duration, interval duration between, for example, 8 a.m. to 8:30. So any production that we produce within that period, we take the sample, not at particular instant, but at during the duration that period we select sample. So in this case, what we call this the sensitivity of control chart. Okay, so we have R chart. Okay, R chart is more sensitive in this case because we have longer duration that we take sample. Okay, but X is not so sensitive because when we compare the average, we take average for longer period. Okay, compared to another one, the difference is not so significant relatively less significant compared to art chart. Okay, let me share the slide here. Okay, do you see my slide? I think I already shared, right? What do you see on the screen now? Can anyone respond to me?
The control chart for variable.
Okay, you have seen that, all right, okay. It's not moving. Let me go back. Yeah, because this is on cloud, cloud. So okay, hello.
Yes, Doctor.
Yes.
Right. Okay, continuation of last lecture. Okay. 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 Contour chart for variables. So this contour chart is like X bar chart. Okay, and also R chart. Okay, these are contour chart for variables. Okay, we have another chart. Okay, we call it attribute contour chart. Okay, attribute contour chart is where we are using for example, go and no go gauges. Okay, go no go gauges. Okay, for inspection, or we just use inspection by looking at with using our eyes. Okay, whether it is yes or no. Okay, fail or no fail. That one is we call it attribute. Okay, but if attribute with variables, we are measuring using, for example, using micrometer, which is we got measured values. Okay, any instrument that can give values. Okay, for example, micrometer or ruler or tensile strength. Okay, or maybe any equipment, any devices, strain gauge. Okay, that is giving values when we do the measurement. So this is, we call it variables. So what chart we use? We use X bar chart and also R chart. Normally the chart are using together. X is for the mean, R is for the range. Okay, so variable mean measured values in terms of numbers. So that numbers we plot. But when you go to attribute control chart, there is no measured numbers. What we know is only is it can go or cannot go. Like go and no go gauges. We just do quick inspection to check dimension of not dimension, the quality of hole. For example, we put this gauge. If the gauge can go, meaning that it satisfy our requirement lah. But when we put the other side of the gauges, which is no go, and the dimension, the hole that we inspect also cannot allow these gauges to go. So meaning that it is within our expected dimension. Okay, or we do just normal inspection to see whether a product is good or bad. Okay, our decision is either good or bad, or accept or reject. This one is attribute. So we don't have the values in such situation. We don't have the measured values. We just have the result, yes or no, go or no go, pass or fail. Okay, pass or fail saja. Okay, so these are two category of control chart. So attribute control chart we will learn later. Example of control chart, we have P chart. Okay, we have P chart. P mean proportion chart. Or we can have NP chart. Okay, NP. N meaning that we multiply the number and multiply with proportion. So it becomes the number of defective units, okay, or non-conforming units. Okay, or we can also have C chart. Okay, we have C chart, we have U chart. Okay, so these are example of attribute control chart. Okay, for variable there are many other chart, but first we just look at X bar chart and R chart. Sometimes we use it X bar and S chart. Okay, S chart. S is for standard deviation. For standard deviation. So range, it is simpler compared to S chart. So we can use X bar chart, R chart, or X bar chart, S chart. Okay. Okay. So these are just general introduction on different type of chart. So let's go more detail on variable control chart, which I explained already last time. So when we say that we use trial control chart, revised control chart, is applicable for both type of chart. It can be for variable chart and also can be used for attribute control chart. Okay, so the law of nature, okay, we know that it's not possible to produce exactly same item. I mentioned already this last time. No item are exactly the same. There will be variability in production. So small variation, item appear as identical, but if we use precision instrument to measure, there will be differences. So three category of variation. Okay, when we produce part, okay, we produce part. So we call it within piece variation, or piece to piece variation, or time to time variations. Okay, so variation can happen within the piece. Let's say you have one piece, okay, one block of whatever product you produce. The variation is happening within this piece. Okay, within this piece, there is variation within this piece. Okay, for example, the surface, this side may be smooth, this side may be very rough. Okay, so another variation is we call between this piece and another piece. Okay, when we produce many pieces. So we compare between piece number 1 compared to piece number 2. Okay, so there will be variation also. It's not going to be exactly the same. So this is what we call it piece to piece variation. Okay, and also another variation is due to the time. Okay, time to time variation. What we produce at 8 in the morning, okay, compared to 8:30, okay, there might be also variation. Okay, this variation is because what? Because of time. Okay, time of production is not the same. Okay, when we produce maybe at 9 and other products, okay, also there will be variation. Okay, the issue now whether we can accept or not this variation. Okay. Okay, what are the source of variations? Okay, because when we prepare control chart, okay, the purpose is to identify the nature of variation, whether is it random variation or is it assignable variation. So sources of variation could be coming from equipment, okay, maybe the tooling, okay, the tool already wear, or maybe machine vibration, or maybe fluctuation in electrical supply, or many other possible causes from the equipment. Okay, maybe in terms of material, okay, material are not uniform. Okay, the quality of material, or maybe also environment, temperature. In the morning is low temperature, in the afternoon, in the noon time, it get hotter outside, and then it will affect the expansion of material. Okay, it could be like radiation, humidity, and also can be pressure at different height of the building. Okay, low level, ground floor, different pressure compared to maybe you are in the level 10th floor, for example. Okay, pressure will be different. And operator, okay, operator skill. So
Assalamualaikum, Doctor.
yeah,
Sorry to interrupt. Can
okay,
I ask something?
okay.
Have you shared the slide?
You don't see the slide?
No. I can see the slide. I mean, in PDF.
Now you can see, right?
Yes. Can see.
Okay, okay. Later on, I will put in e-learning. Okay, is it what you mean?
Doctor. Yes, Doctor.
Okay. Okay, so variation could be also due to inspection. Okay, variation due to inspection. It could be the equipment that we use for inspection also having problem. Okay. So okay, okay, we have seen this many times already. Okay, a control chart, X bar chart, center line is X bar, control limit is, okay, this is upper control limit, this is lower control limit, and this is central line. Okay, so we use control chart to display this over the time as process progressing. Okay, we follow the time sequence in series. Okay, we follow in series, in sequence. Okay, so it goes like this. Okay, so you can see that how the variability happening, okay, when we do the inspection. Okay, so using this graphically, we plot it, and we can see visually the variability. Okay. Okay, I already mentioned that we need to have 3 sigma. Okay, this is 3 sigma. This go to 3 sigma. This also go to 3 sigma. How we decide the control limit is based on 3 sigma. Okay, X bar chart is for central tendency. R chart is for dispersion. So actually, if we plot this as normal distribution, a stable process will display a normal distribution. So we plot. Okay, we plot this, we get normal distribution. So this is where the process is stable. Okay, except this one point, it could be outside here. Okay. Okay. Okay, how do we prepare control chart? Okay. So these are the step procedure to establish control chart. First, you need to decide, okay, what are quality characteristics to monitor. Okay, this could be thickness, it could be the strength of particular piece, or it could be chemical properties, it could be material properties. Okay, so it could be if you are dealing with electrical component, it could be in terms of resistance, it could be current, anything that can be measured. Okay, especially this when we establish X bar and R chart. X bar and R chart. Okay, so we need to define which characteristic that we are measuring. So in a piece of products, there will be many characteristics. So we find only the critical one. Which part are critical? Okay, critical part. And then we choose the rational subgroup. Okay, this is what I was discussing last class, rational subgrouping, where we need to select samples. Okay, how do we do the sampling? Okay, so it could be instantaneous or it could be period of time. And then we do collect data collection. And then we determine trial central line. and control limit. So this is phase 1. Okay, up to this is phase 1. Okay, which is trial. And then after that, we establish a revise. Okay, this is going to be phase 2. Okay, so where we eliminate assignable costs and then we achieve the objective of improvement. So this is another way of showing this instant time period. You select everything during this period. Okay, so this we call instant time method. Select sample at one instance. Okay, so the characteristic of sample that we have is minimal variation within subgroup. Within this subgroup, okay, G1, group number 1, group number 2. Let's say I mentioned last class we need, for example, 25. Okay, so you continue G25, for example, 25 subgroup. So within the subgroup, okay, within for each subgroup, there will be minimum variation. Okay, but maximum variation among subgroup. Compare the subgroup of all the subgroup. Okay, subgroup 1 compared to subgroup 2, compared to subgroup 3, you will have maximum variation. Okay, maximum variation among the subgroup. Okay, these are the most common method. Okay, where X bar is more sensitive than R. Okay, in this case, X is more sensitive than R chart. R chart is less sensitive. Why? Because okay, the R is taking within that instance only. Okay, instance only. Okay, this is period of method. Okay, period of time or period of method. Okay. Okay, let me get my power sekejap. Okay, sample are produced over a period of time. So we take this, I think it's clear now. I repeat this many times already. Okay, so in this case, R is more sensitive. Okay, R is more sensitive. Why? Because you have longer period. R, remember, R is maximum value minus minimum value. So when you take sample within a period, so of course you get higher variability. Maybe at the beginning is low value, maybe somewhere toward the end it's higher value. So the R value will be higher. Okay, will be a higher difference. So this is what we meant, maximum variation within subgroup, but minimum variation among subgroup. So if you compare this group, compare to this group, compare to the next group, compare to the next group, so it's not so sensitive. Okay, minimum variation among subgroup. Okay, so in this case, R chart is more sensitive than R chart. Okay, so when we plot contour chart, as I mentioned earlier, okay, remember this X bar, this is typing error there. So we normally we pay X up. Okay, together we do this couple. Why? Because R is the mean, monitoring the mean. X is monitoring the mean, R is monitoring the dispersion. Okay, remember that you have this. One is monitoring the centering, the other one is monitoring how this value disperse. Okay, how it disperse. Okay, dispersion. Okay, another way of monitoring this, we call it X bar and S. S is standard deviation, which is standard deviation. If you take this as a population, it's a sigma. Okay, monitoring this. This is more accurate actually. Okay, because S is more accurate compared to R. But the problem is you need bigger N value for S chart. S chart, at least you need 10. N equal to 10. Okay, for S chart, at least N equal to 10. But for R chart, you can even use chart for, okay, in this case, you need, for S chart, you need at least N equal to 10. But in the textbook, some exercise, they even give less. But actually in statistics, at least you need 10. But for R, you can have n equal to 2 because to get the R value, you just need two numbers, maximum and minimum. Okay, so but it is cheaper to produce X bar chart, X and R chart compared to X and S chart. Okay, in this case, the period of time method. Okay, period of time method. So lot must be homogeneous. Okay, same machine. Actually, not only for instant time period or period of time. This is for all control charting practice. We must make sure that we don't mix. Okay, must monitor same machine using the same control chart. You cannot mix different machine for the same chart. Okay, and also same operator. Okay, same tooling, because when you mix up different operator, different machine, okay, so that variability we cannot monitor actually the process variation because the machine already mixed, operator also mixed. Okay, so ideally we need homogeneous, okay, homogeneous sample. Okay, another guideline is when we decide the sample size. Okay, sample size bigger, of course, is better, but it's more costly. And normally we use n equal to 5. Okay, n equal to 5. So every sample we take here, okay, n equal to 5. Even though I say that we can use n equal to 2, okay, especially when the sampling is expensive. Okay, but in practice, normally people use it n equal to 5 for X bar, and R chart. Okay, if you use X bar and S, people will use 10 at least. Okay, at least 10 for n value. Okay, there is a guideline for sampling frequency. This is given by document MIL STD 414. This is a table that can guide us. Okay, how frequent that we should take the sample. Okay, so as general guideline, the sampling should be enough to detect process change economically. Okay, but if we're not sure, we can refer to this document. Okay, this is a standard document. MIL means military standard lah. Okay, military standard 414 table. Okay, to assist how frequent we want to take sample. For example, your process is running from 8 okay, to 5. Okay, you want to implement control chart. So now you want to know how frequent. What should be the interval? Okay, is it going to be every hour or is it half an hour or randomly or how? Okay, normally we take it at specified interval. Okay, so that we can have the true picture of the process variation. Okay, this is what I mean. How frequent? Okay, but to have a control chart, you need at least G equal to 25 subgroup. Or if it's too expensive, you even can have 20. Okay, so but not less than 20. Okay, you can have it 20 to 30. But normal practice, people take it 25. In order for us to be able to have a good control chart. Meaning that between here to here, you need this number. Okay, 25. Okay. So every time you take sample, n equal to 4 or 5. Must fix lah. If you take 4, it must stick to 4. If you take 5, it stick to 5. Okay. This is general guideline for X bar chart. Right, to control limits, okay, I mentioned this last time, X double bar plus 3 sigma X bar, okay, this X bar, okay, for X bar chart, plus minus, okay, upper control limit, lower control limit, okay, lower control limit. So you're going to have X double bar plus minus 3 sigma X bar, okay, this is for X bar chart. For I think there is something wrong with this typing. Dia lari sikit. This should be Okay, let me erase this. It's becoming confusing now. Okay, what is showing here is X bar chart. Okay, so this is X bar chart. Okay, X bar chart. Upper control limit, normally we put the X bar here to show this upper control limit for X bar. X double bar is the center line plus 3 sigma. Okay, sigma X bar. Okay, so this one buang lah. Okay, for lower control limit X bar, so X double bar minus, this is X sigma, just the opposite of this. Okay, opposite of it. This is positive and this is negative. Okay, itu saja. Okay, untuk R bar, R chart, untuk R chart, for R chart, we have R chart is like this. You have R in the middle, which is R bar. This one will be R bar plus 3 sigma up. Okay, this is upper control limit for R. For lower control limit, you're going to have just opposite of it, which is minus here. Okay, so what is what I'm showing? Okay, so in practice, it has been simplified this way. Okay, because why in the past, as I mentioned earlier, okay, there is no calculator. In the shop floor, they like to make it very simple. So what we do is replace this. Okay, 3 sigma X bar is being replaced by A2 R bar. Okay, A2 R bar. So same also here. So A2 is coming from table. Okay, you get a table, so you can see what is the factor for this table. Okay, so for R chart, okay, the formula is simplified this way. You're going to have upper control limit D4 multiplied by R bar, D3 multiplied by R bar. Okay, all these are coming from table. Okay. All right, see example here. Let's say you have summation of X bar. Okay, you have some summation of all the sample. So we have this. Okay, summation of R, you have this. Given G, it is number of subgroup 25, and it's for determine trial control limit for X bar and R chart. Okay, so it's very simple here. So summation of this X bar 160.25 divided by 25. So you get this as central line 6.4. Okay, 6.4. Okay, so when you have this R bar, okay, summation of Ri divided by 25, you get this. Okay, so now you are ready to have a contour chart or X bar chart. Okay, what you need to know now, you already have R, so you need to get the A2 value. Okay, A2 value. So look in the table, you get A2 value for n equal to, what is our n value? Hello, what is n value in this example? It's given as 4, right? N equal to 4. Look in the table for n equal to 4. So A2 is 0.79. Okay. D3 is kosong, 0. D4 is 2.282. Okay, this is just look at the table. Okay, and then we just plug in into this formula. You get these values. Okay, I think straightforward. And now let's say after you have plot, you found out that some values are not in control. Okay, for example, this way, you may found out that there are points outside. Okay, so after investigation, you know that this point was assignable cost. Okay, assignable cost. You must know that this is assignable cost. Okay. If we cannot identify actionable cause, we cannot remove it. Okay, so we have to discard this data or revise. Discard the data. Meaning that we remove that data. Okay, so especially when we do the revise control chart, which is phase 2. We revise control chart. Revise control chart. Whenever we have any point which is outside control limit, is showing that process is unstable. So we remove that. Okay, we discard the data. Okay, so a process can be statistically stable or statistically unstable. Statistically unstable, so we assume that actionable cause and then we remove. Okay, so the issue now, how do we remove? Okay, how do we remove? Okay, I think I have it here. Okay, how do we remove data? Okay, there are two ways of removing data. For example, now you have 2 points, okay, 2 points here, which is outside that, but here only 1 point. Okay, so when you remove, you can remove it based on the control chart. In this case, 2 points outside, so only that particular value is removed from that X bar chart. Okay. Okay. When you working on R chart, you just remove this value for R chart. Okay. So another way that we do is we remove this for X bar chart for these two values, and also for R chart also we remove the same values. Also can be done like this. Okay. So we remove the values that are affected for X chart and also for R chart. So because if we remove only this value, okay, so for the R chart, but actually this value also have problem for X chart. So if we remove both, even for these values, 1, 2, 3, see this one is okay inside, but if we remove here, we also remove here. Okay, so meaning that both values are removed. So if we have initially we have n equal to 20, okay, but in the revised one, we're going to have n only equal to 18. Okay, so our x double bar also will be okay. Okay, for example, in earlier one we have summation was okay. I just take example here. Summation of 16025. Okay, 16025. Okay, n is 25. 16025. Yeah, this one was 25. Sorry, 25. So you get 23. So these are 160. Berapa tadi point berapa? 160.25.
25.
Okay. 0.25. Okay. So we minus this value, we minus this value. Okay. And then divide by 23. So we will get x double bar, we call it x double bar new. Okay. X double bar new. Ni siapa dia ni, main music pula ni. Main kelas ke? Kemana tu? Alright, so we will see the example later. I just show the theory first. Okay, let's say now we are using S chart. Okay, S chart ni it is more accurate compared to R chart lah. Okay, R chart is only 2 values, but this one is normally at least 10. 10 n equal to 10. So this chart for variables. Okay, sample standard deviation is used rather than R. Okay, so the S chart Okay, so what we have is okay, the control limit for X bar chart using X and R, sorry, and X and S. Okay, so we have this formula. Okay. Okay, ni nak mai kelas ke mana ni? Okay, if you use, you're going to have upper control limit here, X double bar. Okay, plus A3 okay, A3 S bar. Okay, now it's different. Previously, what was this value for X bar and R chart? Can anyone respond to me? Previously, for X bar and R chart, kita guna berapa? A berapa?
A2.
A2 R bar. Okay, but now A3 S bar. Okay, so when we go down, ini adalah when we are using X bar and S chart. Okay, so you're going to have here X double bar minus A3. So A3 also from table. Okay, from table. So, okay, so for the S chart, okay, for the S chart, so what we do is we have this S here, S bar, okay. So this one will be B4 S bar, okay. All these are trial, this is still trial. Okay, this is trial, X bar and R chart. Okay, meaning that process still not stable. We have not revised it. We have not removed any ensemble cost. Okay, so this will be B3, B3 S bar, 3 S bar. Okay, so we also can do this revise. Okay, the revised control limit. Okay, let me rewrite this. It's not so clear here. So for the revise, okay, you can use either this symbol like this, X double bar new. Okay, meaning that the revised central line. Okay, or sometimes they use this symbol. Okay, so but be consistent the symbol that you use. So you have summation of X bar minus summation of whatever you discard, okay, the value of what you discard, divide by the number of G originally, maybe 25, and the G that you discard, okay. So this is the value that you remove, you throw away. So for the S bar, the center line for the revise, okay, summation of S, summation of D. Okay, for R chart also the same. The difference is the symbol, only the symbol. So when we're talking about the revise, G minus PD. Okay. Let me also write here for R bar new. R bar new mean the revise lah, the revise. So Tadi saya lupa nak sebut kat sini, summation of R minus whatever R that we discarded. So G minus GD. Okay. So this RD, SD, XD, maybe not one value, can be two value, three value, depend on how many which is outside the control limit. Okay. So when we simplify the control limit here, okay, this one, sebenarnya menunjukkan for X bar revise, okay, you can have this symbol new, okay, plus instead of A2, now we are using A. Okay, A sigma naught. Okay, okay, this formula pun lari juga ni. So the bezanya adalah dia punya okay, tanda minus saja untuk lower control limit. Okay. So you have sigma naught here, sigma naught. So sigma naught is can be estimated. Okay, can be estimated from this one, from this one. This is sigma naught, where you have S naught meaning that as new lah, okay, as new. Okay, you can represent this sebagai as. Sometimes people use it as naught as a standard value. So divide by C4. Okay, divide by C4. So this is where you get this value, sigma here. Okay. For control limit for S chart, we use this one. Okay. So now B6 and B5. Okay. So, okay, I think we take a break for 10 minutes. I will show you some example. Okay. I'll show you some example after this. Okay, any question before we break?
No, Doctor.
All right, so take a 10-minute break and I'll show you some example how to use this formula. Okay, can we continue? Please check your Telegram. I already put 2 files in your Telegram. Hello, can you hear me?
Yes, Doctor. Yes.
Yes, Doctor.
All right, go to your Telegram. I already share with you 2 files. Okay. Okay, this file. Okay. Okay. So this is one of the file that I share. Okay, we have discussed this. Okay, we have discussed this. Apa screen saya ni? Okay. Okay, this is what we discussed last class. Okay, before we discuss an example, okay, let me explain about central limit theorem dulu. This is very important concept also. Okay, have you heard about central limit theorem? Hello, what is central limit theorem? You need to understand this central limit theorem related to rational subgrouping also. Anyone?
Is it the normal distribution that standardized to sampling distribution?
Okay, sometime when we take sampling, we don't get a normal distribution. It might be triangular distribution, it could be uniform distribution, or maybe unknown distribution. Okay, so when we take sample with a certain number, okay, we take the average and we plot the averages, okay, rather than the individual values. So the tendency for us to have normal distribution is there to eliminate, okay, distribution which is not normal. So the central limit theorem, as I show in the diagram here, okay, so it is very important for us, okay, to have the sample mean. Okay, this is sample mean. That's why in control chart we use X bar, okay, sample mean, okay, rather than individual values. Okay, this is distribution of sample mean. So meaning that the distribution of X bar, okay, sample mean distribution. But if you plot the individual, this is X, okay, X value. You plot the X, the distribution of X. So it can have this shape, or maybe uniform shape, or maybe this shape like this, okay, or shape like this. So when we want to use this data for control chart, it cannot be used, okay, cannot be used. So what we need to know to use is a data that follow normal distribution. Okay, remember that control chart, the concept is normal distribution. So this can be solved using what we call it central limit theorem. Okay, I'm sure if you have studied statistics, okay, this theorem should be already learned. Okay, so the central limit theorem says, given a sufficiently large number size, sample size, the sampling distribution of the mean, okay, sampling distribution of the mean, okay, sampling distribution of the mean, okay, fault variable will approximately, okay, approximate normal distribution. Okay, regardless of whatever you have here, when you take sample mean, it's going to show normal distribution. Okay, regardless of the variable distribution in the population. Okay, regardless of population that you have here, but if you take it sample, for example, you take it instead of individual value, you take it average of say 5 values. Every 5 you take average. Okay, every 5 take average, and you plot that averages, you're going to show normal distribution. Okay, this is what central limit theorem says. It's very powerful theorem and theory. So this enables us to have control chart. Okay, this will hold true regardless of whether the source population is normal or skewed. Okay, provided the sample size is sufficiently large. Okay, usually, if you take it 30 or more, you're going to show normal distribution. Okay, so if population is normal, then theorem hold true for sample, even for sample smaller than 30. Okay, if you take it 20, for example, so roughly this normal distribution is still valid. Okay, for a random sample that we take from the population, we can compute the mean of the sample. Okay, so this is where we get this. So we estimate the mean from the mean of sigma bar. Sorry, the mean of X bar. Okay, so for standard deviation, okay, of X bar of the sample, it is sigma of population divided by square root of n. Okay, so this is how we get the standard deviation for X bar. Okay, so this is coming from central limit theorem. So, and also last class I explained about this. I explained about this, why we take X bar, not X. Okay, this one is coming from X. This one is coming from X bar. Okay, so you see that X is we have removed the random variation. Okay, so it is more relevant for us for control chart, for control X bar control chart. We don't use this. We don't use individual. There are cases we use X bar chart, but if possible, try to use X bar instead of X chart. Okay, so the value of X sigma of X bar is smaller actually compared to the sigma of the individual, because see the sigma of individual is very large, the dispersion. So how do we adjust that? So because of sigma of X bar is smaller, so this is the formula we use. Okay, sigma of population divided by square root of n. Okay, so in this case, okay, the n here is 5. Okay, average of 5. Every point here is average of 5. Okay, any question on this central limit theorem? Okay, okay, let me show how we can use this formula. Okay, any question? Hello?
No.
All right. So what I'm showing now is example of X bar chart. X bar chart.
Sorry, you stopped the recording. Can you continue recording?
Okay. So this is X bar chart, right? X bar chart. X bar chart. You see here what we do here. Okay, let me erase this. Oh, cannot erase anymore. Why? Maybe last time I used this. Okay, let's say you have this sample. Just see the sample. You have basically subgroup lah. You have G1, G2, G3, G4, G5 until G20. So every G you will take, in this case, n equal to 4. Okay, in this case, n equal to 4. Okay, let's say you want to plot X bar chart and R chart. Okay, so every time you take, okay, maybe you are taking here in terms of instant time period or period of time. Okay, I mentioned earlier, which method is good for X bar chart? Instant time period or period of time?
Instant.
Instant. Okay, instant time period. Meaning that that particular instant we take 4 samples. So now we want to know what is R value and what is X bar value. Okay. So when we want to prepare this, remember that at the end we want it X double bar here, and we want it value of R bar for X chart and for R chart and for X bar chart. So we calculate the R. R is maximum. What is maximum value in this subgroup number 1? What is maximum value? Can anyone respond to me?
5027.
Okay, this one is the biggest, right? This is the biggest. What is the smallest? This one, right? Okay, the smallest. So the biggest minus the smallest, you get this. This is the R value, 0.0018. Okay, so X bar is just already shown here. Okay, already shown here. X bar is the summation of all these, 0.14 plus 0.014, 0.5014, 0.5022 plus 0.5009 plus 0.5027. Okay, add all this, divide by 4, you get this value. Okay, that's X bar number 1. You continue with the subgroup number 2. Okay, do the same. Get R, get X bar. Number 3, you get R and X bar, and so on. Okay, until you finish that 20. And then now you get the what is the X double bar. Okay, X double bar, which is you will take all the number in this row, in this column, which is X summation of Xi. Okay, in this case, this example, Xi, I will be 20 here. So this equal to 1. We divide by 20. Okay, so where you get the value of this column until 20. So that is the value of X double bar. Okay, this value will go to here to make this line. Is it clear to this point how you can create X bar chart?
Yes, doctor.
All right, good. Okay, so to get the upper control limit is not difficult now. Okay, you know that, just add A2 R. A2 R what? R bar, right? Yeah, R bar. So how do you get R bar? R bar is coming from here. Okay, all the 20 values. Okay, so R bar, okay, summation of Ri, okay, divide by the G, 20. So here is 20. Here is equal to 1. Okay, so which is this one. Okay, so you get R bar. So this is go to here. Okay, so how do you get the upper control limit for R? You use the formula D4 R bar, and this is D3 R bar. This is for trial, So if there is any point outside, you remove it for revise contour chart. Okay, so okay, I already give you this, share already with you. Okay, this formula, D4 R bar, D3 R bar for R bar chart. Okay, this is example of the table. Okay, this table you can get this value. Okay, based on this is what we call it control chart factor. Okay, from the table where you get here from A2, you get the value D3, you get D4, and there are many other values. The complete table. The other file that I share with you has a complete table. Okay, so based on this, for example, n is equal to 4, and then you see this is the value for A2, and this is the value for D3, and this is value for D4. Okay, in the past, this is very useful because last time there was no calculator Okay, the operator also have limited knowledge in mathematics. They are use table. But now, since we have computer very easy to use, we can use the complete formula for that. Okay, so okay, and then we plot the value. Okay, this is the formula x bar chart. Okay, the a value. Okay, so this is formula very popular because normally we use 4 or 5 only. Okay, 0.729 or 0.577. Okay, in this case we are using n equal to 4. Okay, so I think you can go through on your own list when you're doing the revision. Okay, let's say there is one point here outside. This is outside because this already control limit. This point showing that something is wrong with the process. Okay, so we need to investigate. If we know that it's assignable cost, we remove this and we revise the control chart. Okay, so here, find the assignable cost, eliminate the problem, okay, and repeat the cycle. Okay, so okay, I think that's all for this file. Okay, let me show you the other file. Okay, the other file also in your, any question up to this point?
Not yet, Doctor.
Okay, so go to the next file. The next file is example of question. You should start to be ready, because next week I'll give you test. Okay. Okay. You can use this as basis for your revision. Okay. I share with you which one is now. Let me check. Okay, review question, right? Is it correct? I think so. This is the one. All right. Okay, you have this one, right? Everyone, can you check? Someone, please confirm to me. You have.
Yes, Doctor.
All right.
Yeah, Doctor.
Okay, so this is can be your tutorial exercise question. Okay, make sure you are able to answer some of all of these questions. Briefly discuss what should be responsible for quality organization and provide justification. Okay, in a table format, what is type 1 error, type 2 error, discuss performance recognizing process variability in process control chart. Okay, we also have done this Pareto. Okay, this question is Pareto. So try to do this exercise also. And number 2 also Pareto. Number 3 also, I think the Pareto. Number 4, this is related to cause and effect. Sorry, I think Pareto also Pareto. Okay. This one is fishbone. Okay. And this is histogram, normal distribution, standardized normal, process capability. Okay. So this is something related to what you have done on scatter diagram, on, no, this is on histogram. Okay, you plot using histogram, the weight and height. Okay, this is, you need to plot. Okay, the question here, sketch the shape of process variation based on your analysis, interpret your finding. So basically you need to plot histogram. Okay, the question is not about height and weight, but it is 30 pins produced, okay, produce 30 pin emitter produced in a machine shop. Okay, this is something wrong, bin, not bin. Produced in a machine shop. So you get this data. So the question asks, analyze the above data and find related statistics to describe the process variation. So basically what you have to do here is to find the mean, okay, to define the standard deviation and to find the mean, okay, to find the mean. So this is sample. Okay, you get the mean and you get the standard deviation. Okay, sketch the shape of the variation based on analysis and interpret your finding. Okay, so you need to plot, basically testing your understanding on histogram. Okay, you get the mean, what is the mean, and you get what is the standard deviation. Okay. Okay, the question number 2 is 30 plate produced in a fabrication production is shown in table 1. Total sum of measurement is 498. Okay, so the sum already given. So what you really need to do is analyze the data, describe the process variation. Okay, again, this is understanding of distribution. Scatter shape, please analyze and interpret. So it's almost the same as previously. Okay. What will change the shape of process variation if data were collected based on subgroup instead of individual? Okay, so this is related to central limit theorem. Okay, central limit theorem. Okay, the mark is 2. Is just to get your understanding on the concept. All right, so determine the process capability index, CP and CPK for the above process if specification of this. Okay, in this one, I think I have the answer at the bottom here. You need to just check. But before you go to the answer, please try yourself first. I think the answer is for different one, for different question. Okay. And in a test, normally we'll give you a formula like this. Okay, formula like this. Okay. Selected formula, we provide this. Okay. So some of the formula you may have not studied yet, but this is formula, you have studied this. I have to explain this. Okay, CP, okay. CPK, not yet. This one you have seen this. Okay. To get the sigma, okay, you can get R note here, meaning that this is R, the revised R. Okay. The S, okay. So this one already familiar. This one also familiar. This, okay. So, and this is for revise. Okay. This is for the revise. This is for revise, formula for the revise, the one that I explained earlier. Okay, revise control chart for R, okay, for X. Okay, so this is the revise. Okay, for the S, I already explained just now this. Okay, the others you have not studied yet. Okay, this one not yet. Okay, this one is on attribute. Okay, just go through this. Okay, let me explain the example here related to this one. I think this one I've not explained to you yet. Okay, see this one. This is related to normal distribution and process capability. Okay, a workshop is producing metal bar. Okay, this is related to control chart also. When we do control chart, when a process is instability, okay, we can look at the process capability and compare with tolerance. Okay, a workshop is producing metal bar to specification with diameter of 25 plus minus 0.3. The measured data reveal that the bar diameter are centered at 25.03 mm and the average sample standard deviation is 0.15. Okay, so it's given here center. Center means the mean. Okay, and average sample standard deviation. Okay, so this is meaning that this one. Okay, is given there 0.15. Okay, and it's 10, assuming the company can sell all the good plates, inclusive the rework, and at $20 per unit. And the scrap unit is sold at $4 per unit. Assume process is normally distributed. Estimate number of units that will be scrapped, okay, and the number of units that require rework if the monthly production is 1,000. Okay, so this question is asking the understanding of how you can relate process variation to tolerance. Okay, so since you are given this, okay, this one is given. Okay, this one is given. So this is basically specification. So you know that upper spec is 25 plus 0.3. So this is upper specification limit. Lower specification limit is just a minus of this. You get this. Okay, sample standard deviation already given here. Okay. Any problem so far, everyone?
No, doctor, but since it's about graph and chart, right? So for the test, did we need to use the graph paper?
Not necessary. If you have graph paper, it's really better, but a sketch is enough.
Oh, so we can free hand draw it?
And freehand drawing. But if you want to use graph paper, also can. But if you just sketch, your sketch is good enough, and then it's acceptable.
Right, doctor. Thank you.
Okay. Okay, now remember what it's saying here is metal bar. Metal bar. Metal bar means something like this. Okay, something like this. So what happened is we need to relate because the question asks here, assume a company can sell all the good, I think not good plate, good bar, the good bar, metal bar, all the good bar lah. Okay, including the rework. $20, 20 ringgit per unit, and the scrap unit is sold. Okay, the scrap meaning that the one that cannot be repaired. So when you have this, okay, you need to relate to this. Okay, when you get a bigger one, you mean you can rework, right? Rework if bigger than upper specification limit. But if the metal bar is smaller than specification limit, can you rework or not? Can or not? Someone, please?
Cannot.
Cannot, because it's so expensive to do another layer of plating and so on, right? So what you need to do is smaller, you have to scrap. If it is bigger, you can grind it and make it, make it as close as possible to the specification. So now the issue is rework or scrap. Okay, so if it's a bar, rework when it's larger, scrap when it is lower. But if you have a hole, sometimes you need to produce, let's say, drilling. Okay, if it is a drilling process, okay, the drilling process, where is the scrap? Okay, for drilling, is it smaller or is it bigger? Let's say this is a hole.
Smaller. Bigger, doctor.
Okay, so when it is bigger, you must go to scrap. Okay, so scrap will be here. Okay, when it's a hole, when you have a hole, your hole is bigger. When it's bigger, very difficult to add more metal to be acceptable. But when it is smaller will be on the left side in this case. So this will be rework. Is it clear, everyone? But in this case, this is metal bar. Okay, this is metal bar where you rework when it is bigger and then you scrap when it's smaller. Is it clear, this one? The concept of rework and scrap.
Yes, sir.
All right. So now, based on this question, we want to know, okay, we want to know the estimate number of units that will be scrapped and the number of units to be reworked if you produce 1,000 units. So now we need to know what is the area of this shaded area. Okay, what is the area of that shaded area? So, okay, let me erase this. Okay, go back to the normal distribution here. Okay, you need to find because we need to estimate number of units that will be scrapped. Okay, need to be scrapped if it's smaller than this. So we use this formula. Okay, this is the formula where you have Z. Remember this formula? X bar X. Okay, X minus mu divided by sigma. Okay, so because we want to know the scrap, right? The scrap. So the scrap may be lower specification limit. This is lower specification limit. Okay, this is lower specification limit. Okay, the lower specification limit will be the scrap. So this is standardized normal. The formula for standardized Z transformation here is standardized normal. Okay, remember that when you have standard normal, okay, whatever value that you have, okay, you can transfer to standard normal, where the standard normal will show this shape. Okay, standard normal normally we represent like this, n 0, 1. Okay, so this is 0. 0 will be the center, and the standard deviation will be 1. Okay, so this is what we call it standard normal. So this is a table from a standard normal. Okay, table is standard normal. You can see this table, the standard normal here. Okay, I cannot erase this. In the last time, erase it immediately. Okay, so this is a standardized normal. The center is 0. You see here 0 there? So this is 0 what I show. Okay, so and then there is Z value. Okay, there is Z value. The Z value is here. The Z value will be the value on this. Okay, this is Z. Okay, you can find the Z value on this. For example, if Z equal to 0, okay, Z equal to 0, so meaning that this one, so the area here will be 0.5. Okay, because standardized normal, this formula, okay, in the center here is Z equal to 0. If you have here, maybe Z equal to minus 3, and somewhere here, maybe Z equal to plus 3. Okay, Z equal to plus 3. So now, because we want to know the percentage, okay, the percentage, so we can use this standardized normal to answer this question. Okay, if you go back to the question is asking, okay, the question is asking, okay, as okay, assume the company can sell all the good product, okay. Assume, okay, estimate number of units that will be scrapped, okay, number of scrap. and the number that unit of rework. So basically they want to know the area of this using lower specification limit, and this is upper special limit, the area of this and area of this. So because this is not a standardized normal, we convert this into standardized normal. Okay, convert this to standardized normal. So we put it in this formula, and we get it the z equal to minus 2.1400. Okay, so go to the table, 2.1400. So the value happen to be somewhere here in between this. Okay, you can do interpolation. So if you don't have time interpolation, you just show that it's between this, and we can accept the method lah. Okay, or you can use this interpolation. Okay, using this interpolation. So the area will be okay. Okay, so we have okay, it will be 0.9839, but because we want to on the left side will be 1 minus. Okay, 1 minus 0.9839. Okay, because area under the curve is 1, so if we minus to the right, because it's positive and we want it the negative one, so it's going to be 0.0161. So meaning that only 0.16%, okay, 0.6% will be scrapped. So out of 1,000, it's going to be 16.1. Okay, so and to determine percentage for rework, when the product diameter is bigger and it's possible to meet the specification by grinding such. Okay, so if you want to get the rework, okay, you get on this side. Okay, what is the area of this? Use the same formula. Okay, same formula. So upper specification limit minus the mean divided by the sigma, and you get the area and to the left. Okay, area to the left. So and then now 1 minus the area, you're going to get 0.4006, which is about 4%. About 4%. So multiply by 1,000, you get 40.1 will be rework. Okay, any questions? For those who have studied statistics, this is just a revision for you. For those who have not studied, maybe you need to spend more time lah on this. Any question on that? Hello?
No, Doctor.
Right, clear. Okay, make sure that when you use the sigma, you can use this formula. Okay, this sigma, sigma equal to this formula in this formula sheet. We also give you this several choice of getting that values. You can have that value of the sigma either from sigma naught equal to R naught divided by D2. So this is R naught here is same as R new lah for the revised chart. Revised chart is considered a stable chart after we do when we remove the assemblable cost. See, R naught here is in the revised contour chart. This is considered as R new. So in this one, we can use D2, but in your example just now, what is used was S chart, okay, based on S chart. If it is based on standard deviation, so you can use this formula. Okay, sigma, estimated of sigma equal to S divided by C4. Okay, so because what was given in the question was standard deviation for sample, so we can use this standard deviation for sample. this one. Okay, and you can use these values, okay, in this calculation here, sigma here. Okay. Okay, the next question is asking on monetary values. Okay, because in industrial engineering, we always convert to values for decision making. If the production cost is 15 ringgit per unit and rework is 3 ringgit, okay, suggest how the company can maximize the profit. Okay, you produce 50 ringgit, you rework 3 ringgit. Okay, how can we maximize the profit? Assume the entire rework unit can be sold and the scrap can be eliminated by process center adjustment. Okay, if the scrap is to be eliminated, the company can adjust the process center such as scrap will be 0. Okay, so now we see that here, okay, this is the center, but now this center produce some scrap and also produce, okay, you have this, let me draw again. Okay, currently the centering is there. Okay, so this one, because it's smaller, you need to scrap this part. Okay, scrap. This part you can rework. So how can we eliminate the scrap? Because the scrap is losing, because the scrap is, you see here, the scrap unit will be eliminated by process center adjustment. How can you eliminate the scrap? Hello? How can you eliminate this center 25.03? How do I know this 25.03? This is from the question here. Okay, from the question here is, the question here is, you know the center. Okay, the bar diameter are centered at 25.03. So at this center, it still produce scrap and rework. So how can I eliminate scrap? Can anyone answer to me? Okay, quickly, because we almost finished. How can we eliminate this? Because scrap, I cannot do anything, but rework, okay, I can improve the rework. How?
Shifting the mean?
Yes, you need to shift the mean. So that here, you shift the mean. Okay, when you shift the mean, this is your mean, right? Now you shift the mean to here. Okay, so you get a new mean. Okay, the new X bar. So now you eliminate this. Okay, so you have more rework, no problem. Rework, because you can sell the rework. Okay, you can sell the rework. So more rework. Okay, so this is what this graph is showing. So the new setting. Okay, you get more rework here. Okay, more rework. Okay, so how much you need to spend for rework? The question already stated here. Rework only costs 3 ringgit, but your production cost is 15. Okay, so just add another 3 ringgit, you can get good products. Okay, so what you need to do now is to solve this. Okay, new shifting to the right, there will be no new scrap. So LSL minus USL remain the same, no change. The new process setting is 23.315. Okay, so the new setting will be this setting, new setting. Okay, so now you need to calculate how much is the new scrap. Sorry, how much is the new rework? Okay, So you need to know this. Okay, you need to find this, the new. Okay, this is given here. This is coming from this formula. Okay, z equal to 24 minus 0.7 minus mu1. Mu1 is the one that we are looking for. Okay, so divide by that. My semi-scrap is 0. Z value will be, okay, in a table. Okay, when you have 0 here, it will be very close to minus 3.99. 3.99, because there is 0 after that. Okay, so basically if you have this curve, okay, this point, after that almost nothing outside, so this is minus 3.99, this is plus 3.99. So if you look at in this table, you can see here almost 3.9, and then you go to this one, 3.9, and this is almost every point already inside. Okay, 3.99. Okay, so almost negligible outside. So that's why we use it 3.99. Okay, 3.9. So there is no outside, almost no lah. There is small number but insignificant. So by having that, okay, we put it here, it's almost 0. So now you can know that the new setting should be this one, 23. Okay, so by having the new setting, you're going to get it, new rework will be 460. Okay, 460. Okay, so that's why we get it this value here, 2.25315. Okay, so now we want to know how much profit. If you can understand this question, okay, meaning that you understand how to use statistics for decision making, for improving the process, and finally, to maximize the profit by eliminating the scrap to become 0, eliminate scrap to 0, maximize the profit will be, okay, your profit will be, remember that additional 5 ringgit for rework. Okay, this is the formula. 5 ringgit is quality of good product, 2 ringgit is quality of rework. I think 5 ringgit here is the profit, to maximize the profit. Okay, so now you get 3614. Okay, 5 ringgit and 2 ringgit is given here. Okay, from the question here, how much is selling? I think it's okay, this formula. Profit of good product, quantity of good product multiplied by selling price, production cost. Okay, what is the selling price? Selling price, I think, is given in the question earlier. Okay, so the selling price is 20 ringgit. If the product is good, okay, you get 5 ringgit profit. If no good, you get it berapa ringgit tadi? Yang rework cost 3 ringgit kan? You only get 2 ringgit. Okay, so kalau you scrap, maknanya your production cost 15, okay, lepas tu you jual metal scrap, so you rugi. Okay, you rugi sebab you dapat spend berapa tadi? Spend 15, tetapi you dapat 4, so you rugi 11. Okay, so okay, please go through this again to get understanding how we can use statistics, scrap and rework, and standardized table to make decision to maximize the profit. Okay, any question? You already have this, already put in your Telegram. Any question?
No. No.
No question. Okay, if no question, I think that's all for today. Okay, maybe I would like to hear from you, someone. Can you summarize what we learned today for the last 2 hours? Any volunteer? Okay, what you learned today? Hello? Tak suruh panggil nama ke? Just quickly help us to recall what we learned. Semua senyap je ni. Faham tak ni? Okey. Apa ni? Kong Chuan. Kong Chuan. Apa nama saya pun tak tahu ni. Eekon Chun. Okay, what you
Yes,
learned today?
doctor.
Yeah. What is your name?
Kong Chun.
Kong Chun.
Yeah.
Kong Chun. Okay.
Yeah.
Kong Chun. Okay. What you learned today?
Control chart for wearables.
Okay.
X bar chart and R chart. X
Okay.
bar chart is for mean, and then R chart is for range.
All right.
And then the normal distribution just now that exercise.
Okay.
And then
That's all.
yeah.
Okay. Shahda Aulia. Okay, Shahda Aulia. Can you add what else you learned today? Ada tak ni Shahda? Okay, Zuhair. Zuhair ada kan? Zuhair.
Ya, ada.
Okay, Zuhair, apa you belajar hari ni?
Hari ni kita belajar there are two methods for sample selection. One is period of time method, di
Okay.
mana there is for the period of time method there will be a maximum variation within subgroup and minimum variation among subgroup. And then the another method is called instant time method. That's for that's for our chart is the best. And then minimum variation within subgroup and maximum variation among subgroup. And then we also learn about central limit theorem.
Okay.
Yeah, where size is n bigger than 30.
Okay. That's all?
Yeah, that's all.
Okay, Rizky Zulin. Okay, what is central limit theorem? Hello, Rizky. Okay, siapa-siapa lah. Okay, please. What is central limit theorem? Okay, Tai Yao Wen. Tai Yao Wen. What is central limit theorem?
Doctor, I can't see your slide, so.
No, I'm no need to see the slide. I just asking the question.
Yes. Sorry, I can't hear you. Can you repeat?
What is central limit theorem?
Central limit theorem is something like in the how say independent random variable which we sum up. Is it?
Okay. Why we use central limit theorem?
to know the distribution of sample?
You not sure lah ni. Tak tepat lah. Okay, Nur Atira. Nur Atira, why we need to use central limit theorem? You only faham, tak faham saya ajar tadi ni. Tadi kata okey aja semua. Okay, Nur Atira, tak ada. Nama ada ni tapi tak ada jawapan. Okay, Hafiz. Hafiz Dika. Hafiz. Hello Hafiz.
Doktor?
Oh, tak. Ya, Hafiz. Dengar tak Hafiz?
Halo doktor. Halo doktor.
Okay, tak dengar Hafiz. Okay, Fatimatul. Hafiz, okay.
Ya doktor.
Ya, dengar tak soalan apa?
Tak dengar.
Kenapa tak dengar? Tak dengar? Tak dengar soalan? Okay, can somebody please answer me? Okay, Abdul Rahman. Abdul Rahman. Okay, Abdul Rahman, what is central limit theorem?
It's tell us that no matter how the shape it will be, the shape of the sampling distribution will approach normal distribution.
Okay, if we take what? Individual or sample?
Excuse me?
Okay, it doesn't matter what distribution. So in order to get it normal distribution, what we need to do from the central limit theorem approach? You get my question?
We take the sample size.
Okay. We take the sample. Okay, we take the sample instead of individual values. Instead of individual values, we take sample. And then we plot the average of the sample instead of plotting the individual values. So we're going to get, normal distribution. Okay, this is central limit theorem says. You may have individually as triangular distribution, or you may have uniform distribution. But when you take averages, let's say average of 5, every 5 numbers you take the average. Every 5 numbers you take the average. You plot the averages, you're going to get normal distribution. Okay, this is central limit theorem. Okay, we want to avoid of having non-normal. Okay, because control chart or quality control is related to normal distribution. How to do it is based on normal central limit theorem. Okay, I would like you to try out the question that I just put it in your Telegram. That's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Okay, one more announcement. On Wednesday, you're going to have 1 hour class at 12, right? I will be busy on Wednesday because I have an official duty that overlap with your class. Can we shift that class to Thursday or not? What time you free on Thursday? Hello? Can anyone? Okay, I will ask you on the Telegram. You respond to Telegram when you free on Thursday. So we will arrange a replacement class for. So on Wednesday no class, but we will replace on Thursday. Okay. So please respond to my message in Telegram later on. Okay. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
So the test did will do on the class on Monday, or when or what date?
On what day? I prefer during class.
Oh,
we can
so I see. So it will be on Monday.
Okay, let me check. Monday, next Monday is 22nd, right? Okay, can we have
Yes.
can we have on Monday during class, 1 week from now?
Yes,
Okay,
doctor.
all right. So it will be, you need to switch on your camera and we will record the session. Okay, so make sure that you are able to